Hey guys, how you doing? Today we're gonna be learning about why is the derivative of a linear function its a slope, okay? You might seem intuitive, but I just want to show you the background of all of that, okay? So let's dive into it. So now we're gonna start by defining a function that is a linear function. So we're gonna say it has a slope of 2, that's a 2, plus a y-intercept of 1, okay? Now, this is a pretty simple linear function. We know it would be a line something like this. We have this, and we're gonna say 2, so it would be up here, the first point, so it would be something like that, okay? And it keeps going. So now, what is the derivative of that? Now, some of you might know that the derivative of this function is just simply going to be the slope of the function. If you remember one of my last videos, I said, and well, it's not that I say it, but it's like that's how math works. if you have a function that has a variable and a bunch of constants, and well, you should be able to put them together so you get one constant. But the thing is, if you have a variable and you have a constant, you can forget about the constant and just take the derivative of the variable, okay? In this case, we could literally just take the derivative of 2x, and that should be the same derivative of 2x plus 1. Let's see what we get if we do that, taking 1 into account. So in this case, we should get the limit as h approaches 0 in the function 2x plus h plus 1 minus initial function, so we get 2x plus 1. All of this divided by h. Now how much is this? I'm going to keep going down here. So in this case, what we're going to get, I'm going to distribute it right there. And yeah, you're going to see what happens. Plus 2h plus 1 minus 2h minus 1 divided by just h. Now what do we get here? These two terms are going to cancel out. And 1 and 1, they're going to cancel out. And we're gonna get 2h divided h. Now how much is this? That's just gonna be 2, okay? So this limit, without even plugging in 0 into that equation, we know that's just gonna be the f prime is gonna be equal to 2, which is the slope that we have for our linear function. It is absolutely the same thing as if we took as if we considered 1 or not. Just imagine that if I don't plug in this 1 in here and I don't plug it in here, I'm just gonna get this same part. This one is not gonna exist and this one's not gonna exist, and these two are gonna go out and you're gonna get the same thing, okay? You do not need to consider the constants. In our previous video we said why we should not consider constants when taking derivatives, okay? Or why they go to 0 basically. So now, this is the slope or the derivative for this linear function. Now, remember that derivatives, you can see they're like their most pure essence if you have functions that have curves, right? If you have just a line, what is going to be the slope of that line at any x point? Well, of course, it's just going to be the slope that you have for the linear function, which is just going to be 2. And that is what this derivative is telling us. No matter for what x point you have, that is why we do not have an input for this function, we just have a constant. Remember that in other functions we did have an input for the derivative. In this case we do not, because for every x point is going to be constant the slope, okay? Which means that the derivative is always going to be a line. If you can actually plot derivatives. The derivative in this case, if we say this is f prime of x and this is x, it's just going to be a line in here, and that's just going to be 2, okay? And that is basically how it goes. So if you have the graph of a derivative and it's just a straight line, well, you know it is a linear function. So I hope you got some intuition into why if you take the derivative of a linear function, well, you're gonna get back its slope, okay? It's pretty cool, and I think this gives intuition and knowledge into all these derivative things. And well, I just really enjoy derivatives, so I hope you enjoy them too. So I hope you guys enjoyed this video and see you in the following one. See ya.